In this video, we're going to look at using integration to find areas above and below the x-axis. Previously, we had just concentrated on finding areas above, but this time around, we're going to look at how having areas below the x-axis complicates matters a little bit. I have got the straight line y equals 2x minus 4, and I've got this bow tie shape shaded in. We can see the bow tie shape goes from 5 down to -1. So I have set up my integration with 5 and -1 being my limits. And I have then worked carefully through it and ended up with a final answer of 0 units for my shaded in area. Now, clearly, this is not correct because, well, I've got a shaded in area. I have got some area, so an answer of 0 isn't right in this case. What has happened here in my working is I have not taken into account that this shaded in area is in fact made up of 2 separate areas. I've got one area above the x-axis and one area below the x-axis. And what has happened is these 2 areas have essentially cancelled each other out. So I've got the same problem as I have before. I'm going to calculate the total area bounded by the graph of y equals 2x minus 4 and the x-axis, and the lines x equals 5, x equals -1. So I'm going to start by making a quick sketch of this. So I've got my x and y axis. I'm going to have a straight line 2x minus 4. So I know that is going to be a positive gradient with a negative y-intercept down here. And I've got an upper limit of x equals 5. So my upper limit is going to be up here, where this is 5. And my lower limit is going to be at -1. So down here. To calculate the area of this bow tie shape between the line and the x-axis, I need to treat it as 2 separate shapes. So I'm going to calculate this area first. To do this, I need an upper limit and I need a lower limit. Here, I've got an upper limit. This is going to be the lower limit of this first section. I am essentially finding a root for this line. I'm finding its x-intercept. So its x-intercept is at y equals 0. So I am going to take the equation of my straight line and set it equal to 0. Solving that gives me an x-coordinate of 2. So this point here, where the line crosses the x-axis, is 2. I'm going to find the area of this blue shape, so I'm going to label that 1, just like a composite area shape you'll have done in first, second year. And I'm just going to get stuck in. The area of that shape 1 is going to be the integral of 2x minus 4 with respect to x. My upper limit is going to be 5. My lower limit is going to be 2. The -1 has nothing to do with my area in this case. 2x is going to integrate to, well, x squared, and then I would divide this by 2. 2 divided by 2 will give me a single x squared. -4, that'll integrate to -4x. And I'm going to have my upper and lower limit to substitute into that. Substitution, I'm going to plug in 5 first. So 5 squared minus 4 lots of 5, subtract 2 squared minus 4 lots of 2. So this bit here is me substituting the 5 into my integral. This bit here is me substituting the 2 into my integral. I can work through this number work. First bracket, 25 minus 20 will give me 5, minus 4 minus 8 will give me negative 4. 5 minus negative 4 gives me positive 9. That is the first area. I'm now going to figure out the second area. I don't need to worry about the fact it's cut by the y-axis. All I'm worried about is the fact that all of this here is below my x-axis. So I'm going to figure out this area. I'll call this area 2. Area 2 is going to be the integral of this function here. I'm still working with the straight line 2x minus 4, so that does not change. What does change is my limits. My upper limit is going to be 2 this time. My lower limit is going to be the negative 1. So this green shape is between 2 and negative 1 on my x-axis. I don't need to think too hard about the integration because it's already been done. So I can just copy that from the line above, x squared minus 4x between 2 and negative 1. So I'll end up with 2 squared minus 4 lots of 2 minus negative 1 squared minus 4 lots of negative 1. Working through the number work, 4 minus 8 gives me negative 4 here. Minus negative 1 squared, that'll be positive 1, add 4 will give me 5. This means the total area for this second shape is going to be equal to minus 4, minus 5, minus 9. So here we can see where the 0 on the previous page came from. The first area was 9. The second area, this green area, is negative 9. So adding these together is actually cancelled out to give me 0. Every time you find an area below the x-axis, you're going to get a negative answer here. So this is why we need to do it in 2 separate parts. Find the above area first and the below area second. To find the total area, we need to essentially just ignore the negative here. So I'm going to end up with area 1 of 9 plus area 2, which is a size of 9. So I'm ignoring the negative symbol. Adding that together will give me 18 squared units. Now, it is important that for this below the x-axis area, you get a negative, and then in a separate step, you show that you have dropped the negative and just added everything together. Here's another example. I want to calculate the area bound by the curve y equals x squared minus 9 and the x-axis. So here we have our little diagram set up. X squared minus 9, so a happy parabola. Y-intercept, this should be negative 9 down here. I've got the x-axis. I've got the shaded in bit. So the first thing we need to do is we need to figure out what our limits are going to be. So these 2 points here where it crosses the x-axis. So our x-intercept, or x-intercepts I suppose, because there's 2 of them, what we call roots of a quadratic, that is going to be when y equals 0. So therefore, x squared minus 9 will equal 0. You can go x squared has to equal 9, so x will have to be positive or negative 3. So those are going to be my two limits. The area is going to be the integral of x squared minus 9 with respect to x. My limits are 3 and negative 3. So remember, the one that's further up the x-axis comes first, the one that's lower goes second. Don't worry about the fact it's crossed the y-axis, that has got no impact on what we do. So my area, x squared, is going to go to x cubed, and I divide that by 3, or take a third of it. Minus 9, that will integrate to minus 9x. Put my square brackets around it, and copy my limits down. I'm going to plug 3 and negative 3 into this. So I have got a third of 3 cubed minus 9 lots of 3, and I'm going to subtract a third of negative 3 cubed, take away 9 lots of negative 3. So as I said in a previous video, total sort of non-calculator territory here. I'm going to have 3 cubed and then find a third of that. Well, that's going to be 27, a third of that is 9. I suppose another way to think about that is it's 3 times 3 times 3, and one of those 3's will get cancelled out by the third. Take away 27, because that's what 9 3's are. Then, right here, I'm going to have a third of negative 27. So take care to really think about your negatives there. That's going to give you negative 9. Minus 9 times minus 3 will give you plus 27. Tidying this up, I'm going to get negative 18 minus positive 18. Negative 18 minus 18 is going to give me negative 36. Now, what you cannot do here is you cannot just shove on units squared and finish there. You need to be showing that you know how to deal with this negative. It's not enough to also just do this to go, well, I'll bin the negative. You need to be really clear with your communication. So the way I would do this is I would have this comes out as negative 36, and then actually write a statement. So, shaded area is 36 units squared. You need to acknowledge the fact that there is a negative answer, and then you need to show the fact that you know you need to drop that negative. So, just to wrap up, coming back to this previous example and having a look at these little bullet points that were here. So the first thing you want to do is either examine or make a sketch for yourself and examine where it is above the x-axis and where it is below. You will need to either calculate or read off of the graph where your upper and lower limits are. Really important you pay attention to where it crosses over the x-axis. Second point, calculate the area above and the area below separately. Your area above will be positive, your area below will be negative, so it's okay to get a negative answer for below. Your third and final step is a completely separate statement. You're then going to find your total area by ignoring your negative signs and adding the numbers involved together.